All right, so today we're graphing inequalities. So we have less than or equal to, and greater than or equal to. These are our inequalities, and we're going to graph them. And we're going to graph them by using a number line. We're going to graph them by using a number line. So when we have an inequality answer, remember an inequality answer. An inequality answer is a range, correct? How many answers are there to an inequality? Infinite answers, right? Because if it's greater than 10, that means 10.1, that means 10.2, that means 11, that means 44, that means 1,764. I mean, they're infinite answers. So we have to show how they're infinite answers. So if I gave you a value, we're going to have a number line. And you're welcome. There's a number line printed on your homework. And we need to remember that the solution to an inequality is infinite. It's not everything, because are there numbers that don't work? Yes. But there are infinite answers because it goes on forever. It's a number line. Right now. We'll have some more parameters set later, but right now it's just going in one direction forever. So if it is a greater than or a less than, if it is a greater than or a less than symbol, it is what's called an open dot. If it is a greater than or a less than symbol, it's an open dot. Like if it said greater than 10, I draw an open dot at 10. If it is a greater than or equal to or less than or equal to, if it includes the equal to, it is a closed dot. So if it said m is greater than 10, I draw a circle at 10. An open dot. If it said m is greater than or equal to, I'd color in the dot. I'd fill it in. It's called a closed dot. Thank you, Mrs. Porter. You're the best twin ever. If it is greater than or equal to, which way on a number line do things get greater than? To the right. We shade right, or some people think of it as up, like going up, even though it's really to the right. It's not a vertical number line, it's a horizontal number line, but some people think up. And if it's less than or equal to, which way do numbers get less than? We shade left. Or some people like to think down. Now the key is, when we're shading, when we're doing all of this stuff, you have to think about what are possible solutions to this problem, right? Like what makes it true. So we're going to draw some quick graphs. They're not going to be lengthy. But if I had then like x is greater than or equal to -6, x is greater than or equal to negative 6. I'd have my number line. I'm going to put negative 6 in the middle. I'm going to go up 1 to negative 5. I'm going to go down 1 to negative 7, correct? Is that true? Because it's negative, right? So they go the opposite way of a positive value. Is this an open dot or a closed dot? Open or closed? Closed, because it could be 6. Because where I'm shading, whatever's colored in on my graph is a possible answer. And is negative 6 a possible answer? Yeah. Negative 6 is possible. And this reads x is greater than negative 6. So which way is greater? To the right. Any number in there. Is negative 5 a solution to this? Is negative 4 a solution? Yes. Is 12? Yes. Is negative 6.1? No.
Yes. No.
Which way is negative 6.1? It's that to the left of negative 6, so it does not work. If I had y is less than 4, really quickly I'm going to do 4, then I'll do 5, and I'll do 3. Again, your number lines are already created for you. Is this an open dot or a closed dot?
Open.
Why is it open? It cannot be equal to, so it cannot be 4. So I cannot shade in 4, so I have to leave 4 open. 4 is not a solution. Over here, negative 6 could have been a solution, so I colored it in. But here, 4 is not a solution, so I draw a fence around it. Like, don't come in here shading. Stay out. Get off my yard. Right? Y is less than 4, so which way is it going to go? To the left. Now here's the trick. Some of you may notice a little like, oh, Mrs. Long, wait a second, I see something about the shading. But hold on. Let's do 10 is greater than or equal to t. So I'm going to put 10, correct? And I'm going to go 11, and then I'm going to go 9. Is it an open dot or a closed dot at 10? Closed. It is a closed because it could be equal. Now, some of you may say, Mrs. Long, I noticed on the first two, you shade whichever way it points. Did anyone notice that? Yeah. Look. You shade the way it points. But what do these have in common? The variable comes first. The variable's on the left side. If the variable is not written first, you cannot use that trick because I'm not going to shade up because it tells me 10 is greater than or equal to t. We need to read it variable first. Do you agree? So I need to read it backwards. Read it backwards. T is less than or equal to 10. So I like to, this is my personal preference, and you know, I'm really good at middle school math. I like to rewrite it. These are the same. And if I rewrite it so that my variable is first, I can use that trick of it goes the way it points. Because t is less than or equal to 10, meaning less than or equal to is down below. Do you recognize how these are the same? Because the inequality, for lack of a better term, opens to, it eats the 10, correct? So when I rewrite it, my inequality still has to open to and eat. The alligator eats the bigger thing, right? 10, the alligator's eating 10 over here, so over here the alligator needs to eat 10. It's the same thing reading right to left as left to right. It just sounds different, but it means the same. Questions about graphing? Open dot, closed dot, shading right or shading left. Good to go?